Okay, so the idea is this: if you have let's say you have the coordinate system here, the x, y coordinate system. Now, what happens is if there's a point here, then in the x, y coordinate, in the Cartesian coordinates, which is the x, y system, this point is x comma y, meaning that this is x and that is the y value. This is the x value, that's the y value. So if that's 3 and that's 2, then this point is 3 comma 2, for example. Now, in polar coordinates, what happens is this point can also be described by this distance right here, which is called r. Okay, so r is the distance from the origin, which is 0, 0 to the point. So that's the square root of x squared plus y squared, that distance there. And then this angle right here, theta. So it can be described with theta comma r. Okay, so it can either be described with xy, Cartesian, or theta comma r, which is polar coordinates. Now, what happens is this angle is, so this is y and that's x. So this angle, the tangent of this angle is y over x. That's one way to look at it. And then you have these two things right here. If you have this theta and this r, then your x, okay, so if you look at it, so maybe you could look at it this way. If you took the cosine of theta, this angle, it would be x over r, right? So that means x is r cosine theta. And then if you took the sine of theta, the sine of this angle would be y over r. So that would give you this right here, y equals r sine theta. Okay, so these are the basic formulas involving to convert between polar and Cartesian coordinates. Okay, so if you have polar coordinates to convert to Cartesian, you do this. You use this formula. Okay, so in other words, when you're going polar to Cartesian, so that one you use these two formulas, which maybe I can label them 1 and 2. Okay, you just use those when you're going from polar coordinates to Cartesian. Now, when you're going from Cartesian to polar, the best thing to do is to draw a graph. That's the best thing. And then everything else sort of falls into place. And then use these right here. But usually drawing a graph, everything becomes pretty straightforward as to what you should do. And another thing is, a note about this, when you're doing this, is that multiple values of theta will work. Okay, for the same point. Okay, so for example, theta and theta plus 2 pi are coterminal. Okay, so it's 2 pi is the distance all the way around the circle, all the way around. And so if you have an angle theta, then you come around here to theta plus 2 pi, it's the same angle. And so it's going to be the same thing. So it'll also work in polar coordinates. Now, usually, to get around that, they'll specify conditions, maybe make theta between 0 and 2 pi. And that brings me to the second note. is R is usually positive. Okay, but not always. It doesn't have to be. Okay, so when it's negative, then it does weird things. So if you have this angle and your R is negative, then you're going to be going out this way. Okay, so negative value for this theta, negative values of R will be going the opposite direction. Okay, so this is maybe R equals 4, and then R equals -4 with this same value of theta would put you over here. On the other hand, if you were taking this theta here, if you had the angle coming onto there, and you had negative values of R, it would shoot you out this way. Okay, but usually R is positive, but sometimes it can be negative. So just watch out for that. Okay, let's get into some exercises. So first of all, we plot the point whose polar coordinates are given. So this is R is 5, and theta is 3 pi over 2. And the theta is the angle that it makes with the positive real axis in the counterclockwise direction. Okay, so 3 pi over 2 is this angle right here. 5, that means you start here and you come out 5 in this direction. Okay, so that's going to be this point right here. Okay, not that one or that one or that one. These are different angles. Okay, so the point is going to be 0, -5 for the first exercise. Okay, let's go to number 2. And here we have R is 4√2 and theta is pi over 4. Okay, so here, this is pi over 4. So your point's going to be over here about 4√2 and in this direction. And that looks like this is going to be the point right here. So this is going to be it right here. Now, to get the actual X and Y values, you can use the formulas. So X is 4√4 times cosine of pi over 4. And, no, 4√2. Cosine of pi over 4 is 1 over √2. So that's just going to be 4. So X is 4. And then Y is our sine theta, or 4√4 sine. I don't know why I keep on putting more 4s in here. Okay, everything else is a 4, so I decided to make that √4. So that's 4√2 times 1 over √2. Again, that's also 4. So it's 4 is the coordinates for that. Okay, let's go to part C. Okay, and here's what I'm telling you. R was actually negative here, and theta is also negative. So negative pi over 6 would be this angle right here. Okay, but since R is negative, instead of going out here, you're actually going to shoot back this way, to the 9 points back this way. And so it's going to be this point right here. Okay, because that's, that looks like it could be about 6. Wait, no, 9, I'm sorry. That looks like that distance could be about 9. And this is your angle right here, pi over 6, negative pi over 6, okay? Okay, so X would be -9 cosine of negative pi over 6. Okay, so negative pi over 6, this is -1, 2. Cosine is going to be √3 over 2. So that will be over 9 times √3 over 2. So the X coordinate is -9 √3 over 2. And the Y coordinate is -9 times sine of negative pi over 6. Sine is -1 over 2. So that's going to be 9/2. Okay, any questions up to this point? Okay, let's move on. Number 2. Okay. The Cartesian coordinates of the point are given. Okay, so notice what I said on the first page. When you're converting from Cartesian to, when you're converting from polar to Cartesian, just use these 2 equations. You can also graph it if you want, but which is what I did in those. So in the first exercise, we were doing these. We were doing this right here. Now number 2, exercise number 2, we're going to do this. We're going to convert from Cartesian to polar. And every time, the best thing to do is to draw a graph, because it can be highly confusing. Okay. So here I have the point -7, 7. This is XY coordinates. So I draw a graph, and it's going back 7 and up 7. And there's the point right there. Okay, so the first thing that you have to figure out is what's this angle going to be right here? And since these are the same distance, they're both 7. That's 7. This is 7, although it's in the negative direction. Since they have the same distance, then this angle is going to be 3 pi over 4. Well, this is pi over 4. This is half of a 90-degree angle. So this angle is 3 pi over 4. So the theta part is going to be 3 pi over 4. So can go ahead and put that in there. And then the r part will be, you have a right triangle here, and this is 7, and that's 7. Although it's in the negative direction, but this distance is still 7. So the r part is the square root of 7 squared plus 7 squared. That's a 7. So it's 7 root 2. Okay, so 7 root 2. Now they also want you to do it where this is kind of really weird, because they wanted to oh yeah, they also specify that theta has to be between 0 and 2 pi. Okay, so that means that all your angles are going to be here. From here, this is 0, coming around, this is 2 pi. And 0 and 2 pi are coterminal. Okay, so you want r to be negative. So in order to do that, what we have to do then is come out this way. And instead of going around this, well, okay, we can't go backwards. We can't do this angle here. This is negative pi over 4, but we can't go negative pi over 4. We have to choose this angle here, which is going to be pi over 4 less than 2 pi. So that's going to be, let's see, 2 pi is 8 pi over 4. And one less than that would be 7 pi over 4. Okay, so this angle is going to be 7 pi over 4. That's this angle here. From there all the way to there. And then, since it's coming out here, but we want the point over here, then we make it -7 root 2. And I'll do that. Okay, let's look at part B. So 5 and 5 root 3. So again, the most important thing to do is to graph this. So here's 5 right here. And we'll say that's 5 root 3 up here. And anybody want to guess what this angle is going to be? That's 5. This is 5 root 3, which means that this side...
Pi fourths?
5 fourths?
Pi fourths?
Pi fourths?
Yeah.
No, it would be pi fourths if these were the same, but this is 5 times root. So, but look, if this is 1, so 5 is like 1, this would be root 3 right here, right? Which means this is 2. 1, 2, root 3. Are you familiar with that kind of a triangle? Okay, so here's how it works. If you have, okay, let's say you have a right triangle here. Okay, if this is 1 and that's 2 and that's root 3, then this angle here is pi over 3, and this angle here is pi over 6. And this, of course, is pi over 2 right here. Okay, so that means this angle is pi over 3. And if we're going in the spirit of 1, 2, double 5 is 10. So that's got a big 10. Okay. So the angle is pi over 3, and this distance right here, the radius is 10. So 10 pi over 3. And then here you want r to be negative, and so then you have to choose this angle right here. And again, this will also be pi over 3. So this angle here will be pi plus pi over 3, which is 4 pi over 3. And negative 10, because you're, instead of going out the positive way, instead of going out that way, you're going backwards because it's negative, because they want r to be negative. Okay, any questions about that? Anything so far? I think you get to go back and review a lot of trigonometry that maybe you've forgotten. So it's nice to be able to go back and remember that. Okay, number 3 is we're looking at regions, sketching a region. And so you have this condition, r is between 3 and 5, and the angle is between 11 pi over 6 and 13 pi over 6. Okay, so 11 pi over 6, that is that's pi over 6 less than 2 pi. So that would be, so this angle right here would be 11 pi, 11 pi over 6. That's supposed to be a pi. Okay, and then 13 pi over 6 is actually going to 2 pi, and then you go a bit further. And then 3 to 5 would be, there's 3, there's 5. Something like that is what we're looking at. Which would be, this one. Okay, so notice that you have here, this is dotted. That's why you have these dotted lines here and there. And this is, these are solid. That's why you have this right here. Okay, so the dotted, that's because of this. And solid. And then r goes from 3 to 5. There's 3, there's 5. And then the angle is 11 pi over 6 to 13 pi over 6. So this will be the second question, second one. Okay. Number 4, find a Cartesian equation for this curve, and then identify the curve. So there's actually 2 parts to this problem. So let's handle the first one first. Okay, so you have r equals 9 cosine theta, and we want to convert that to Cartesian. Now, in this case, if you multiply both sides by r, then you're going to get r squared equals 9r cosine theta. Okay, now do you recognize r cosine theta from something we said earlier in class? R cosine theta, or r squared. On the first page.
Isn't r cosine theta x?
Yes, exactly. This is x, so that's 9x. And r squared, do you remember what r squared is?
X squared plus y squared.
Exactly. Okay, so r squared is x squared plus y squared, and r cosine x is 9x, is x. So we have our x squared plus 9x, but x squared plus y squared equals 9x. That will be the equation that you'll input. as the first answer. And do you know what kind of curve this is? It's a circle. Okay, it's a circle because what you're going to do is you're going to pull this 9x over here, and then you're going to complete the square. Half of that's 9/2. This is 81 over 4. And then you get this x minus 9/2 squared plus y squared equals 9/2 squared. So it's a circle whose center is 9/2, 0, and radius is 9/2. Okay, so that's a circle. Okay, let's look at number 5. Here we have r squared cosine 2 theta equals 64. Okay, so the cosine 2 theta is not very nice, but there's a trigonometric identity that says that cosine 2 theta is equal to 2 cosine squared theta minus 1. Okay, so we're going to plug this in for cosine 2 theta, and that gives us 2 cosine squared theta minus 1. So r squared times all that equals 64. So distribute the r squared in, and we have 2r squared cosine squared theta minus minus r squared equals 64. Okay, r squared cosine squared theta that's just x squared, right? So that's all that is x squared, because it's r squared. That's r cosine theta is x, but then r squared and cosine, but the r and the cosine are both squared, so that's just x squared. And then this is x squared plus y squared. So you get that, okay? And then if you distribute the negative, then you have 2x squared minus x squared minus y squared equals 64, and then that becomes x squared. So x squared minus y squared equals 64. That would be the answer to the first part for number 5. Okay. But which one of these is it? Anybody want to guess? It's a hyperbola. Okay, so when you have x squared minus y squared, or something to do with x squared, then it's a hyperbola. And the other form for the hyperbola would be x squared over 64 minus y squared over 64 equals 1. Okay, so number 6. Find a polar equation for the curve represented by y equals 8. So here we're supposed to find a polar equation. Now, when you have a Cartesian equation, you just use x equals r cosine theta, y equals r sine theta to convert to Cartesian. So this is pretty straightforward. Just plug. So everybody see a y, you replace that with an r sine theta, and then you're done. That's it. Okay, so that's converting a Cartesian equation to a polar equation. Okay, do you guys have any questions about anything that we've covered right here? Then let's move to the next exercise. Number 7. Look at this interesting graphs. But all 4 of these are really interesting looking. Okay, so let me show you how you can sketch these graphs. Okay. So basically the problem is to sketch this. This is a polar equation right here. And okay, so what you do is this is r equals a function of theta, right? So what I like to do is put theta, values of theta, choose values of theta, and then find values of r. Find out value of r it would give you. And so the first point that I would choose would be 0. Okay, and usually, so typically, theta runs from 0 to 2 pi. Okay, typically. They might give you some limits on theta, in which case you would just start with this left point usually. Typically, you start with this left point, so I start with 0, since it's usually 0 to 2 pi. And if it's not listed as being anything, then you can just take it to be 0 to 2 pi. So start with 0, and then that's going to be 1 minus cosine 0. Now cosine 0 is 1, so that's going to be 0. Okay, so you have the point. Okay, so when you're looking at this angle right here, that's going. This is the angle 0 right here, right? This angle 0 because it's the positive x-axis. Your radius is 0, so that puts you like right there. Okay, now the next point that that's pretty easy to deal with is pi over 2. You can choose intermediate points, but you don't have to kind of get an idea of what's going on. So here, this is going to be 1 minus cosine of pi over 2. Now cosine pi over 2 is 0, so that's just going to be 1. Okay, so that gives you the point pi over 2, 1. So when the angle is pi over 2, that's this angle right here. Then you're up here at 1. Okay, so it started from 0, and as the angle, so think of like this is an angle getting bigger. As the angle went from here to here, you went from 0 all the way to 1. Okay, and so it traces. So out of all these graphs, this one's the one that it's going to be. As it goes from 0 to 1. As the angle goes from 0 to 1, your cosine goes from 1 down to 0. Okay, so your cosine went from 1 to 0, which made this 1 minus the cosine go from 0 to 1 in the radius. Okay, and then the next. So let me choose another point here. Let's go with pi. Now cosine pi is -1, so this is 1 minus a -1, which is 1 plus 1, which is going to be 2. Okay, so here you're all the way out at 2 at this point. So here, as you go from pi over 2 to pi in these angles, your r is getting larger and gets to 2. And then as you come down here, it gets smaller again and goes down. Okay, so this is going to be your graph. Okay, so it's a nice Valentine's thing. It's called the cardioid, by the way. Any questions on that? Let's do another one. Number 8. Okay, so this is r equals 6 cosine of 4 theta. Okay, so here we have theta and r. Okay, and again, you kind of think of theta as going from 0 to 2 pi. Now when theta is 0, what does it give you? That gives you 6 cosine of 0, which is going to be 0. So you have the point 0, 0. The point 0. So when you're doing this angle here, you're at 0. Okay, now for the next point, for choosing the next point, notice that I have a 4 theta in here, and with the previous problem, the next point that I chose was like pi over 2, because when I choose pi over 2, then then cosine goes from. Wait a minute, what am I doing? No. I made a mistake here. I'm sorry. Drat. Cosine of 0 is not 0. It's 1. So this is 6. So you get 0, 6. So your first point is going to be over here at 6. Okay, so it's going to be right. It's going to be okay. So we can already tell that it's going to be Okay, this is just great. So we can already tell that it's going to be, this is going to be the answer. Okay, we can already tell that. Okay, but let me just kind of show you how the rest of this works. Okay. So the next point we'd choose would be power of 4. Would be so that we're calculating cosine of power of 4. And so you take this inside part and set it equal to pi over 2. I'm sorry, pi over 2. And then that theta would give pi over 8. So actually the next point that the next value of theta that we could choose is be pi over 8. And that would give you 6 cosine of, you put a pi over 8 in here, then that's going to be pi over 2. And cosine of pi over 2 is 0, so that's going to be 0. So, and going from 0, an angle goes from 0 to pi over 8, which is maybe like right here. You're going from 6 all the way down to 0. Okay, and then the next thing, okay, if we choose another one, and that's going to look kind of weird, but I'm 2 pi over 8, so pi over 8, 2 pi over 8, which is pi over 4, but you know, but you multiply that by 4 and you get cosine pi, which is -6. Okay, so as you go, okay, that's going from 0 to pi over 8, the angle pi over 8. And then as you go from pi over 8 to 2 pi over 8, you're going from 0 to, you're actually going to negative, from 0 to negative, -8. Okay, so you're actually tracing through this part of it. Okay. Okay, and then the next one. So what's happening as you go from 0 to pi over 8? You're doing that. From pi over 8 to 2 pi over 8, you're doing this. From 2 pi over 8 to 3 pi over 8, you're doing that. And then you're coming up here and going like that. So you're just kind of tracing through like that. Okay, that's how that works. You can continue further, but I mean, we already figured it out. Okay, number 9. So this is applying some calculus to it. And it says, find the slope of the tangent line. Okay, so slope of the tangent line is dy dx. Okay, slope is dy dx. And here we have this equation, r equals f of theta. It's a function of theta. Okay, now we know that x is r cosine theta. And we know that y is r sine theta. Okay, so x would be this f of theta cosine theta, and y is going to be f of theta sine theta. Right? So x is cosine theta over 3 cosine theta, and y is cosine theta over 3 sine theta. Okay. So here we have x and y. These are parametric equations. Okay, the parameter is theta. Okay, so the parameter is theta. And here's our parametric equations. And in the last section, we said to find dy dx, you find dy d theta over dx d theta. Okay, so we're going to go ahead and do that. Okay, so dy d theta, that would be the derivative of this with respect to theta. So it's the derivative of the first part, which is negative 1/3 sine of theta over 3. sine theta plus this one times the derivative of that, which is going to be cosine theta. Okay, so I just applied the product rule to here. Okay, the derivative of this part is negative sine of theta over 3 times the derivative of inside, which is 1/3. This is with respect to theta, and that's negative. Okay, then this one, derivative of this is again negative 1/3 sine of theta over 3 cosine theta plus the derivative of this, which is negative sine theta, and then times the first part there. So just product rule, okay? And finally, they got this part right here. Theta is, okay, you want the slope at the point specified by theta equals pi. Theta equals pi. Okay, so dy dx, theta equals pi would be, just plug pi's in here. Okay, so fortunately, sine pi is 0. So that and that go away. Yay. So that, those two just go away. And then what are we left with? We have some cosines of and sines of pi over 3. So if this is pi over 3, then 1, 2, root 3 works. Okay, so cosine of pi over 3 will be 1/2. And cosine of pi is going to be -1. And then down here, we have negative 1/3. And then sine of pi over 3 will be root 3 over 2. And cosine is -1, so that's, we get that. Okay, so what do we got? The 2's are going to cancel, I guess, and those negatives will cancel this because that's gone. So we're going to get negative. You have a 1 there. This is root 3 over 3, so it's going to be negative 3 over root 3, because this 3 comes all the way to the top, so negative root 3. That'll be the answer. Okay. Any questions about that one? Okay, number 10. Okay, number 10 was pretty nasty. So let's go ahead and get started. Find the points on the graph where the tangent line is horizontal or vertical. Assume theta is between 0 and 2 pi. Okay, so for this one, when you're faced with something like this, the best thing to do is graph the equation first. Okay, and see what we have. Okay, so graph it first, and then kind of see from the graph what's going on. Okay, so to graph it, I'm going to go ahead and put values of theta. Now they're kind of confusing because they put r first and theta second, so that's kind of throws me off a bit. But because you have r equals something, right? So it seems like that r should come second. But okay. Okay, so when theta is 0, then sine is 0, so that's just going to be 1. Okay, and so let me do the graph over here. So when you're this angle, you're here at 1. And when theta is pi over 2, sine of pi over 2 is 1, so that's 1 minus 1, which is 0. So that's 0. So as you go from here to here, you go like that. And then when you get to pi, which is this angle coming out here, you get 1 minus 0, you get 1 again. Like that. And then when you get to 3 pi over 2, which is this angle coming down here, you have 1 minus sine of 3 pi over 2, which is 1 minus a negative 1, which is going to be 2. Okay, so you come down like that. Okay, so you get something like that. Well, this is really badly drawn, but okay, you kind of get the idea. Really terribly drawn. But what can I do? Oh well. I'm cursed with not the ability, with the inability to not draw things very well. Okay, so you want to find all the places where there's a horizontal tangent, and it looks like you can kind of tell that there's going to be one here, here, because it looks like horizontal, and right here. And so this looks like your smallest angle right here, right? And then this looks like your intermediate one, and this looks like the largest angle. So I'm going to say this point right here is going to be your largest one. So you can go ahead and just like even put that down. So 2, and then the angle is 3 pi over 2. Okay, so that's actually this one. We're going to just go right off the bat and just put that in there. Okay, so to find the other two, though, that's going to be a little bit more trouble. To find the other two, we're going to use this right here. Okay. So, but let me set this up here. So you have x will be f of theta. So x would be, I can just write it right here. X is this. And y will be 1 minus sine theta. Wait, sine theta. So this is cosine theta minus sine theta, cosine theta, and then y will be sine theta minus sine squared theta. Okay. So dy dx is going to be dy d theta over dx d theta. Okay, so dy d theta is going to be taking the derivative of this with respect to theta. So that's going to be cosine theta minus 2 sine theta cosine theta. That's the derivative with respect to y. And then dx d theta would be the derivative of this with respect to theta. That's going to be negative sine theta minus, okay, so then we have the derivative of this, which is cosine theta. So it's cosine squared theta, and then plus sine squared theta. Ooh, ouch. Okay, so where you have a horizontal tangent will be where the numerator is going to be 0. Okay, those are potentials for where you have a horizontal tangent. Okay, so here we can factor a cosine theta out. And so you're looking where cosine theta is 0, or where this one actually is sine theta equals 1/2. Okay, this one happens where theta is pi over 2 and where it's 3 pi over 2. Okay, now 3 pi over 2, we have it right there. Pi over 2 we know is not going to work because here, this is not, you don't have a horizontal tangent here. This is a vertical tangent. This is a vertical tangent right here, this point here. It's not horizontal, so we'll throw that one out. And then these two values are going to be pi over 6 and 5 pi over 6. That's where the sine is 1/2. And when the sine is half, this is going to be a half. So these are each going to be 1/2 pi over 6, and then 1/2 5 pi over 6. Okay. Now, vertical tangents. Okay, so that is going to be where the denominator is 0. Now, I'm going to change this cosine squared theta to sine squareds, just so everything's on sines. Okay, so that just setting that equal to 0 will give you where the vertical tangents are. Okay, so this is what is it? Negative sine theta minus 1, and then here you have plus 2 sine squared theta equals 0. Okay, so 2 sine squared theta minus sine theta minus 1 equals 0. Okay, this factors into a 1 there and a plus there. Okay, so this is giving you sine theta equals negative 1/2, and then sine theta equals 1. Okay, so this is one of them. This is where pi over 2. This gives you pi over 2. This one gives you, it actually gives you these 2 points here, I guess. What's that angle? 7 pi over 6 and 11 pi over 6. It gives you this angle. This is 7 pi over 6. And it gives you this angle here, which is 11 pi over 6. Really bad drawing and really hard to see. Okay, so for some reason though, okay, so when you put these values in to here, you get 3/2. Okay. Okay, because when you're subtracting a negative 1/2, you get 1 plus half, which is 3/2. So it's 3/2, 7 pi over 6, and 3/2, 11 pi over 6. Now I don't understand what happened here, but I think that there's a problem with Webassign because it made me put it in this way. Okay, so it says largest theta value, smallest theta value is supposed to be this one, and this is supposed to be the largest theta value. But this is the smallest one, so I don't know what's the problem here. This is really weird. But anyways, and I marked it wrong until I got it. So so I don't know what to say. I will just highlight this, I guess. And put a nasty comment. I'll say, what the? Okay. So I don't know what Webassign is doing, but it didn't get it right until I put it in this order.